Okay, in the last video we got through the first four examples. I want to do a couple more examples here and tell you about a couple more tricks that you'll want to know. This next example, number 5, C2H6 plus O2. This one starts out fairly easy. Okay, I got two carbons on the left. I can fix that. I can put a 2 here. Now I got two carbons on the right. We move on to the H's. I got 6 H's here. Okay, I can fix that. Put a 3 here. 3 times 2, so I got 6 H's over here. The tricky part of the number 5 has to do with the oxygens. On the left, I have two oxygens. On the right, what you want to do is you want to add up all the oxygens. So think about it. I got 2 times 2, so I got 4 oxygens here, plus 3, and there's a little 1 there after the oxygen. We know it's there. It's not written, but we know it's there. So 3 times 1, I get 3 oxygens. So 4 plus 3, I have a total of 7 oxygens on the right side over here. Now, there's a couple different ways to do this. The way I like to do this is something called the 0.5 trick. And the reason I need to do it is if I have 7 oxygens over here on the right side, there's no whole number I can put in front here that's going to add up to 7. Because if I put a 3 there in front of the oxygen, 3 times 2, that's 6. If I put a 4 there, 4 times 2, that's 8. But what I can do temporarily is put a 3.5. And it's always going to be 0.5 something. That's why I call it the 0.5 trick. Because I know that 2 times 3.5 is 7. So it's just a little trick that I do to get it to balance. Now this can't be the final answer because I can't have a decimal number for a coefficient. I always got to use whole numbers out front here. But this is just a trick to get it balanced. Because if I think about it, I got 2 C's, 6 H's, 6 H's, 7 O's over here, 3.5 times 2 is 7 O's. So it is balanced. So what I do to get my final answer is I go through and I double all the coefficients. So the 3.5 becomes 7. The 2 here becomes 4. The 3 becomes 6. And remember, even though there isn't a number out in front of this first chemical, there is actually a number there, and it's a 1. And if I double 1, I get 2. So my final answer for number 5 would be 2, 7, 4, 6 in those blanks. Again, something I call the 0.5 trick. There are other ways to do it, but I think that little 0.5 trick is a good way. So moving on here. Number 6, pretty straightforward one. Two H's, two H's. Okay, H's are done. Two O's, two O's. Nope, I don't have two O's over here. I got two O's on the left, but I need two O's on the right. I only got one O here. So I'm going to put a 2 here. Again, looks like a Z, but that's a 2. So 2, got two O's and two O's. But the problem is when I put that 2 there, it messed up my H's. So I got 2 times 2. I got 4 H's now. So I got to go back and I got to fix that by putting a 2 there. Always double check before you move on to the next one. 2 times 2, 4 H's, 4 H's, good. 2 O's, 2 O's, those are good. We're done. Next up, again, fairly straightforward one. Start with first chemical, 2 aluminums. So I'm going to put a 2 there. So we got 2 aluminums, good. Move on to the next chemical. 3 oxygens, 2 oxygens. Well, so that's kind of a pain in the butt. I got 3 on one side, I got 2 on this side. I'm going to do the doubling trick, or the multiply by 2. So I'm going to make this 3 into a 6 by putting a 2 here, because odd numbers are a pain in the butt to work with. So now I have 6 oxygens, and to get 6 oxygens over here, I put a 3. 3 times 2 is 6 oxygens. So 6 oxygens, 6 oxygens. Oxygens are good. The problem is, when I put that 2 there, it messed up my aluminums. So I have 4 aluminums now on this side. 2 times 2 is 4 aluminums. So I got to go back and fix that, and that should be a 4. I would recommend doing this in pencil when you're actually doing it on a paper. It can get a little sloppy. Unfortunately, I can't erase individual things in this program, but so I'll just scribble it out. So that's my final answer: 2, 4, and 3. Okay, the next one is another kind of tricky one. Looks fairly complicated, but it's not too bad once I realize, oh, PO4, that is on my polyatomic ion sheet. That's phosphate. Same here, PO4, there it is again, that's phosphate. And since it's on both sides, I can compare them without worrying about anything in the parentheses. Now, I also notice I have OH, but I don't have OH over here. Now, this is the last of the main tricks that I'm going to teach you on how to balance is if I see H and OH on one side of the arrow and H2O on the other, I'm going to rewrite H2O as HOH. So let me write this out. So again, I have an OH and an H that are separate on one side of the arrow, and I have an H2O on the other. What I'm going to do is oftentimes it'll help to kind of visualize this and kind of see the correct answer if I rewrite that H2O as HOH. Still the same chemical. It has 2 H's and 1 O, just like H2O, but it's just written differently. And now what that allows me to do is compare the H out front here with the H out front here, and the OH in parentheses here with the OH in parentheses on the other side. So let's start balancing. I'm just going to start with the first chemical here. H is out front. I got 3 of them. Well, here I only have 1, so I'm going to fix that by putting a 3 there. So now I got 3 H's out front, 3 H's out front. Move on to the next thing, PO4. That is phosphate. I don't have to worry about anything in parentheses. I just look at how many phosphates do I have. Well, there's no number there, but we know there's a 1 there. So 1 phosphate, and I actually have 1 phosphate over here. So phosphates are balanced. Moving on to the next chemical. This is a K. It's kind of hard to read there. I got 1 K here. I got 3 Ks here. So I can fix that easy enough by putting a 3 there. So 3 Ks and 3 Ks. And then if I notice, 3 OHs on the left and 3 OHs on the right. So again, I compare the OHs to the OHs, H's out front with H's out front. That's my final answer. At this point, I might just quickly put up the answers for 9, 10, 11, 12. So if you want to pause it, do 9, 10, 11, and 12, and then I'll put up the answers just to kind of conserve time here. And if you like to get some more practice, you can do that. So I'm going to pause it. I'll put up the answers for each individual one. Okay, here is the answer for number 9. If you double check that, you'll see that is the correct answer. Then I'm going to do number 10 here. 1 second. Okay, the answer for number 10. Number 10 was kind of a tricky one. The fact that there are NAs in 2 different spots here can be kind of tricky. So we have 10 NAs here, another 2, so that's 12 NAs on the left. 6 times 2 is 12 NAs on the right. Here we have 2 N's, so 2 nitrogens. Here we got 2 nitrogens. Here we have 2 times 3 is 6 O's, and we got 6 O's. When you first start out, the NAs are balanced. The N's aren't, so I put a 2 in front of the NaNO3, put this 2 here, because I have 2 N's over there. And once I do that, I got 6 O's, so I had to make 6 O's. And once I did that, okay, 6 times 2 NAs, I got 12 NAs. Well, I can't change this 2 because I've messed everything else up, so I put another 10 NAs there. Remember, it's a back and forth, trial and error kind of thing. It's not always going to be real straightforward, so it's a process. If you get stuck, erase everything, start over, try it again. So I will put the answer for the next one up here. 1 second. Okay, here's the answer for number 11. Number 11 was kind of tricky. It was actually one of the ones where doing the HOH trick helps. You notice we got an H out front and an OH on one side of the arrow, and on the other side of the arrow we have an H2O. So I did the HOH trick. I rewrote H2O as HOH. I compared the H's out front with the H's and the OH's in parentheses with the OH in parentheses. So that should be your answer, 2, 3, blank, 6. And again, there's only one right answer here. It's not like, oh, I got 2, 3, blank, 3. Well, no, that would be wrong. There is only one answer. So I'm going to pause it again and do the answer for the last example, number 12. Okay, last example for from the notes is 2 blank blank 2 is the correct answer. Again, you have an OH and an H on one side of the arrow and an H2O on the other, so I did the HOH trick. It doesn't always help. I think most of the time it does help. But in this case, it did. And that is about it. If you're still not getting this, I do have more examples on paper. If you want to stop in, I can give you a worksheet and you can practice this stuff some more. Some are easy, some are tougher. We will be having a benchmark on this, so it's one of our major skills that we learn in chemistry, so it is very important that you learn how to do this. But I got plenty of practice for you. If the practice quizzes and the videos aren't enough for you, again, stop in. I have additional paper examples that you can work on, and we can work on together on an off day or whatever. So that is it for balancing symbol equations. There is one more video on how to balance word equations, so be sure and watch that. See you soon.